Looking at row assembly with all the opcodes and hex values can be difficult. Ghidra allows us to substitute hex values with the string form to ease the understanding process. It also comes with a long list of common names and values that we can use. But what if we have not so common values to be replaced? Like here, we do have a list of hashes that are of the common Windows API that will later be resolved to a function address. But we would like to see the names in the dead listing too. We can manually apply those names, or we can write a script for that. Let's start with the list of imports. The first one allows us to use Ghidra's SetEquate cmd command, and we use path from OS for, well, paths operations. We need the list of key value pairs for our script. Here, I have a long list of hashes with their corresponding names. Let's read them skipping any lines that starts with a hash and put that into a Python dictionary. That gives us the dictionary with the data, though it might be just a bit too much of list comprehension for one video. Next, we need the list of addresses that we want to apply the equate to. We could go with a different solutions here, but in this case the values are in regular intervals, so we could just have a start and an end address and the step. In case of this binary, start is 0x2ba, end is 0x66c, and a step is 0x16. Now, we need to get the const value that exists in the instruction at that address. For that, we use Ghidra's API getInstructionAdd. To convert a number to an actual address, we can use toAddr method. And to get the value, we can use getScalar, passing 1 as an op index. Next, we extract the string value from our dictionary. But before we do that, we need to convert our const value to a hex representation, so we can use that as a key. With that, we can extract the name that we will use, also checking that if the key doesn't exist in our dictionary, our code won't break. And that's all we need to construct SetEquate cmd. First parameter is the string that will be used to replace the hex value. Second is an address. Here again we use toAddr to convert number to an actual address. With the third one, we need to indicate which argument in the opcode we will replace. And the last one is the const value that is to be replaced. What we are left with is only an instruction to execute what is prepared with applyTo method. As an argument to it, we pass current program that is provided by Ghidra's script environment. Now we save the script along with the API hashes txt file in Ghidra's script folder, and we run it from the script manager. That works beautifully. We could of course improve it more. An obvious one could be to allow more dynamic start and end addresses to be specified, but that is left as an exercise for the viewer.